Right, right everyone, this is quite a short video I think. This is going to be annuities again, and it's going to be level ones, continuously paid, and also it's going to be Perpetuities. Hopefully I've spelt that right, but no spell check on a pad of paper. Right, okay, so that's on there, just about on top of the page there. There you go. A bar is the present value of a continuous rate of payment of 1 per period, or per year we'll just say here, just to make it easier on the brain, discounted at I. For n years. Now, on that statement, the key thing here is rate. Usually we talk about an amount of 1, say, at the start of the year, for annuities in advance, or at the end of the year, if it's in arrears. So, this could be an integral. There we go. We also have that delta equals log 1 plus I, and e to the minus delta t equals v to t. Put that in there now, that exponential. Why do we do that? Well, that's easier to integrate if necessary. Otherwise, if we have this, if we leave the v to t, that's when we have that sort of that integral, if you remember from your A-level days, which then is something like that, I believe, from memory, if I put some limits on that, something like that. Anyway, either's fine. V to the t is fine, because we're using an effective interest rate, so that's great. But as we know, as you've got further into your mathematical studies, and as I know from actuarial exams and work, exponentials are handy to have and use. Okay, right. Key for us here is a bar to the n, for the n years, is 1 minus v to the n over delta, which obviously can be derived, which is derived from this. We're not going to concentrate on that. So here I said think about the rate of payment. So here we've got, in this example, was a rate of 1 per annum. But as I say, it gives 1 per annum. So on a cash flow basis, ignoring interest and discounting, cash flow equals 1 per year, which is same. Ignoring interest is the same as 1 whether it's in advance or in arrear. However, we know that that rate is coming in through time. So when we start discounting, the discounted values are different than for an advance and arrear annuity. So if I do that, a 1 year constantly payable one doesn't equal that, and it doesn't equal that. So in terms of rank, that's going to be the biggest. I think that comes in there, and that one should be there. Check that, I might be wrong. And of course this means that I does not equal 0%. If I does equal 0%, then I believe they should all equal each other. I think. Right, okay, so that's the introduction to continuous level annuities. One other thing I mentioned up here, perpetuities, so I'll call them perps for short. Here n equals infinity. So let's do an annuity paid in arrear for an infinite amount of time. We'll use our formula on that. You can see we've got that there. We know that this is, if I is greater than 0, we know this is going to be less than 1. So this gets, if we take over an infinite amount of time, hang on 1 second, press something, infinite amount of time, this tends to 0, so V, that goes to 0, which implies that we have 1 over I for that. Similarly, a double dot infinity is 1 over D, and also a bar infinity equals 1 over delta, just so we've got a complete set. We're going to see perpetuities again later in compound increasing annuities. Okay, hope that helps. Speak to you later.